calibrate our pressure sensor, we have to make sure there are no air bubbles before we hook up a tube and calibrate with different water pressures. So I've got a syringe with some water. I'm going to flood the transducer. That way we know that there are no air bubbles. When calibrating, the effective water depth in a tube is the same as the difference between the open end of the tube and the top of the pressure transducer. So that's a simple way to simulate being under a varying depth of water without having to have thousands of gallons of water to do it. Okay, so we're going to calibrate our pressure transducer. I've got it set at 1 foot on this measuring tape, and I've got a tube with water. So the difference between this height and the water height in here is what we're going to be checking. So I'm going to move 6-inch increments, see the voltage output, and I'll see if it's a linear output based on, you know, it doubles in height, doubles in voltage. So I've got LabVIEW set up. Take 10 cycles per second. Now I'm recording that. I've got everything set up, so I'm going to hold for 5 seconds at each level. So right now we are at effectively 0 inches. Okay, that's 5 seconds there. Gonna move up 6 inches to approximately 18. $48, $54, $60. After holding the pressure transducer under different depths of water, we recorded the voltages at those different heights, and the results are shown. So what you're seeing is a plateau at each 6-inch increment where I held the tube for 5 seconds. So you've got 6, 12, 18, 24, 30, 36, 42, and 48 inch increments. The averages of those values were then taken, and that is how we calibrated our pressure transducer. To calibrate the photoresistor, we only need a few things. One is a variable intensity light. You can see that this light actually, I can choose how bright and how dark it is. And the other is a light intensity meter, which I don't currently have with me. So what you need to do is take your photoresistor and set it up. Make sure you set it up inside the clear box it will be in so that any light loss through the box is accounted for. So you set that up in here, take a light meter that measures in lux per lumens and also put it under here. And then all you have to do is change the light and read the voltage change across the other resistor using a multimeter. So you turn the light off, you measure what the voltage is coming out and say whatever the light intensity is. You turn the light up a little bit at a time, and you take more readings of light intensity versus voltage, and you do that enough times that you have a good data set to make your calibration curve. So I took 18 total readings, ranging from this bright to completely dark, and I measured the voltages at each of those readings, and I used that to calibrate my photoresistor for use underwater. When we're calibrating both the light and the pressure sensor, one of the easiest ways to do that is to take the values that we know from our calibrations of the light and also the water depth, and plot those on a graph, and then use a regression analysis to do that. And so using Excel, Microsoft Excel, you can do that, and you can basically have it predict what the equation would be to fit those points. So that's what I did on both the pressure transducer and the photoresistor. The pressure transducer ended up being a first order curve, basically a line. The photoresistor ended up being a third order curve. So that's kind of a curve that starts and gets bigger pretty quick toward the end. And that's the way that we're able to accurately predict and measure other values. Well, thanks for watching. I hope you enjoy your light and pressure sensor if you choose to build one. Feel free to email me with any questions, and go America.